Okay, so now let's introduce the model. We're saying that there is a firm facing two categories, categories 1 and 2. So the firm, if he wants, the firm is able to enter both categories at the same time. So we assume there's no such capacity or technology constraints. Uh, if the if the firm chooses to be specializing, then it will only enter category 1. Yeah, so we choose it to be category 1 for no reason. And then we assume that the demands for the two categories are independent. The firm has the quality for the products or the services, and the quality may be either high or low. Here we assume that if the quality is high in one category, it will also be high in another category. So we are saying that if one guy is good in doing one thing, he's also good in doing another thing, right? Oh, that's our assumption. This makes the derivations easier, but as the paper discussed, it will be fine if we relax this condition. We may assume that the firm is high in one but low in another, so that's fine. But we will stick to this assumption that the quality may be either high in both or low in both. Look, there are some costs and prices that we need to specify. If we want to serve both markets, we're going to use this M as the label. Or if we want to specialize in one market, we're going to call it a situation S. In either case, we need to pay service costs for our services. Suppose we do multiple services. Then, for service 1 and 2, for quality low or high, the cost is called CJIM. Okay, this M is denoting multiple services, and for quality J for service I. And we assume that the high quality service requires a higher cost. So CHIM is greater than CLIM for no matter I is 1 or 2. If we only provide a single service, then the index here becomes S. And because we only care about service 1, there's only CJ1S as the cost term. In this case, that's the cost for category 1 if the quality is J. J is, of course, L or H. Here, we assume that CJ1M is exactly alpha times CJ1S, and alpha is a greater than 1 number. So the assumption here is telling us that there is a relationship between the cost for the first category for the same service. But if you are doing it in a multiple services, or if you are doing it with specialization, the cost will be different. And if we assume alpha to be 1, that means when you do specialization, the cost is smaller, right? That means when you focus on only one thing, you can do it in a cheaper way without sacrificing the quality. There are also prices that must be chosen by the firm. So if I provide both services and I have quality either L or H, the price is the price is typically called PJIM. But if I only specialize in one service, then it will be called PJ1S as my price. Okay, something about demands. We assume that the consumer's willingness to pay lies uniformly between 0 and 1 or 0 and delta. Here, theta 1 is the willingness to pay for service 1, and theta 2 is that for service 2. And besides the assumption of uniform distribution, here we say that the two market size can be different, and the delta may be either greater than, equal to, or less than 1. So there may be more consumers that care about service 2, or there may be fewer. Yeah, both are possible. The consumer's utility of buying service I from type J firm will be this one. My utility for service I and quality J will be exactly in our standard form. Theta I is my willingness to pay times the quality I get minus the price I pay. But please keep in mind that this formula will be meaningful, or this number can be evaluated only if the quality is public or the two players are engaged in a separating equilibrium, right? Otherwise, you just have no way to make sure that whether the quality is high or low. So if the consumer cannot tell the quality, then the consumer will buy the product if and only if the expected utility here is non-negative. So here, this thing is the expected quality, and we define lambda as the prior belief. So before I get any idea, I'm going to assume that lambda is the probability for the quality to be high, or I'm saying that I believe that's the probability for the Q to be high. And if that's the case, then this thing inside the square bracket is the is the expected quality, and I use that to determine whether I want to buy it. So with all this in mind, if I have a price, then I can calculate the demand, and D will be just 1 minus P divided by Q, and Q may be either the quality under a separation or the expected quality under pooling. Yeah, but in any way, why do I get this? It's nothing but there is a line here between 0 and 1, and if I know the quality is P, then I know if I know the price is P, then I know P over Q is somewhere here, and all those guys with higher theta is going to buy my product. So this part will be 1 minus Q divided by P divided by Q. There is something unclear here. This is the demand for service 1. Right? Because here we are writing 1. If it's service 2, then demand here will be delta, will be based on delta. So yeah, keep that in mind. And finally, with all of them, we can calculate the profit. The profit pi will be the demand times the profit margin, which is the price minus the cost. And under different situations, we may need different indexes or superscripts or subscripts. Yeah, and the firm, we assume that he can always make money in either category. So we are assuming that if the quality is observable, the firm can just make money in either category, especially in category 2, so that we may if there is a specialization, we may highlight the reason as signaling. Okay? So we need to specify the timing. First, the nature will select the firm's quality according to the prior belief, and then the firm will decide whether to serve both categories or just specializing in one. And then the firm will determine the price or prices. After all of this, the consumer is going to observe the number of categories and the prices. Okay? With that, the consumer is going to form posterior belief on the quality. For example, he may believe that I cannot tell it, or he may believe that okay, the quality is high, something like that. Afterwards, the consumer is going to decide whether to buy or whether the offer is good enough. As always, we look for pure strategy equilibria, and we will only focus on separating equilibria. We need to keep in mind that for our games and for most of the signaling games, there will be pooling equilibria at the same time. Okay, Even though we typically care more about separating equilibria because we want to highlight the signaling effect or impact, but there are typically pooling equilibria. It's just that to save our time and to get focused, we will ignore the discussion about pooling equilibria. Okay, so that's about the model.